All right, so this problem, I give you suggestions. Drawing a picture is not necessary, but it may be useful. Okay. My hopes is that we know what this phrase here means. Corresponding parts, congruent triangles are congruent. Now, we're not dealing with triangles here. We're dealing with actually pentagons, right? 5 sides. So this T, instead of saying triangles, maybe we just call it polygons. Corresponding parts of congruent polygons are congruent. If you guys remember back to section 4.1, we had this problem here, right? Now, if you were drawing the picture, this is what you would have gained from that drawing that picture. And then maybe you can relate the parts maybe a little bit easier. But we also said that when we did this problem, we don't need the picture. All right? It says the way we name congruent figures is important because when we just see the name, it should still tell us what is congruent. Okay? So that's what the hope is. That's what the CPCTC or the CPC-PC kind of means for us. All right? If I look at AB, those are the first two letters here. And the reason I look at AB is because we have an expression for AB, right? So what should AB correspond to, Cameron? Careful. Somebody in the last class did the same thing. All right. So those two things that I've highlighted, these expressions down here should be the same, right? Yes. If they're congruent polygons, then their corresponding parts are congruent. So I should say 8x minus 40 is equal to 20x minus 172. Is that doable for everybody? Yeah. Now, it's up to you whether you solve that now or you continue through the problem and find some other congruencies. I'm just going to go ahead and find some other congruencies. The next thing they give me here is CD, right? So CD, so I'm going to go find CD in my name here. So what should CD match up to over here, Cameron? MN. So I find CD, MN, those should match up, and there's another equation. So 16Z plus 60 is equal to 28Z minus 180. And now the last part, they give me what? DE is 60, right? All right, so DE are the last two letters here, right? And NP are the last two letters there, right? But as I search through here, are there any NPs? Nope. No. And there is an angle in, but in your whole in the actual question, I don't know if I still have it up. No. In the actual question, it says find AB, find I think it says BC, CD, and then eventually. Let me double check. Let me see what it does say.
There's like A, B, C, D, and X, W.
Can you see here? Yeah, okay. So see A, B, C, D, X, W, and MN. But you do see that it asks for NP, right? Okay. Well, that's coming from this last congruency. NP should be the same thing as DE, right? DE was 60. Okay, so that one should have been maybe probably the easiest one to come up with. But now looking at this information here, I should be able to solve for X and Z, right? All right, so if I subtract 8X, gives you 12X here. I want to add 172 to both sides. So that should give me 132. And then X becomes 11, right? If X becomes 11, when I plug 11 back in right there, I get 88 minus 40, right? That's 48.
So XW
should also be 48. XW should be 48 because you're saying, well, they were corresponding parts, right? Well, let's double check. If I plug in 11 right there, I get what? 220 minus 172. Okay, that's 48. Is that doable? So that verifies that I've probably done some things correct so far. Come over here and do this one. Find Z. Should give me what? 12Z. Add 180 to both sides. Should give me 240. So Z, or sorry, it's not a Z. Z, 12Z should equal 240, so Z then is 20, right? And now I come back up to CD, 16 times 20 plus 60. What's 16 times 2?
32.
32. So 16 times 20 is 320, right? So 320 plus 60.
380.
Yeah, CD is 380. And then, so CD matched up with MN. So MN is also 380. And you can verify that by plugging in 20 there. Okay, you get 28 times 2 is 56. So that's 560. 560 minus 180 should give you 380. All right. Is that doable? Now they also ask on that question, what is X and D? Angle X and angle D. Well, angle X matches up to angle, what over here? A. So the measure of angle X is 43, because that's what A was. Okay. And D matches up with angle N, right? Okay, so angle D's measurement is going to be 62. Does that kind of make sense to everybody? Now, I say draw a picture. You can draw a picture, might be helpful. Your picture can be drastically different than your neighbor's picture. We haven't really talked too much about what makes a polygon, but it's simply just a bunch of segments end to end, okay, and to where you end up closing your picture off. So, just give you some. Okay, that would be an example of a polygon. Okay, now it's a special kind of polygon. Maybe you guys are more familiar with stuff that looks like that. That's a polygon. That's a polygon. Okay, these are some special polygons. You guys remember seeing stuff like those? Okay, those are referred to as regular polygons. But a polygon is simply a figure that we say is closed. So I could put like an animal in one of these and it not get out, right? Does that make sense? And they have no curves. Okay, so a circle is not a polygon, or any portion of a circle in my image forces that image to be non-polygon. Okay, but if we've got 5 letters, that means we have 5 vertices. So I'm just going to draw just a generic. Maybe that's my polygon. Okay. Now you could have drawn something completely different and still come up with the same conclusions that I'm going to come up with. All right. So the idea is that if you've got these two shapes, A, B, C, D, E, and then I'm going to name this one. So I started at the top vertex there. So I'm going to do the same thing over here with X, and I moved clockwise, so I'm going to do the same thing. So I go W, M, N, and then P. Now you can do the same thing. You don't have to put A where I put A. If you want to put A where I put C, that's fine. But then X would have to be where M is. Does that make sense? Okay. And you could have gone. I went clockwise when I named things. You could have gone counterclockwise. Regardless of how you set the picture up, you will still, as long as you follow the fact that I go from A straight to B, straight to C, straight to D, straight to E, and then back to A. You can't go from A to, you can't let this one be C, and then this one over here be B, and this one here be D. Does that make sense? Because as I move along, you should still trace out the name. Well, this name would be A, C, D, B, E. Not what we wanted. Okay? So as long as you follow those criteria that we set forth already for naming figures, you should come up with the right conclusions here. I'm going to plug in my information. AB is 8x minus 40. CD is 16z plus 60. DE is 60. Over here, XW is 20x minus 172. MN is 28z minus 180. Then we've got A is 43 degrees, and N is 62 degrees. So now my hopes are you see that if I were to lay these two things on top of one another, does AB and XW match up? Okay. Does DC and NM match up? All right, and those then develop your equations, right? What I fear, because this will happen, what I fear is that people will say, okay, I knew that I had to set AB and CD, or not, sorry, not AB, AB and XW equal each other because they both are the ones that had X's in them. Anybody do that? Okay. Don't do that. Do not, just because it's based off the variable, set your inequalities, because we know how to use systems, right? Okay, so we could have multiple variables in an equation, and just by saying, well, X's had to match up and be in an equation, and Y's had to match up and be an equation, Z's had to match up and be an equation, that doesn't have to be maintained. Okay? You have to set your equations up based off of the geometry. Okay. Is that all right? My hopes are you see that this one here was the same thing. Okay? Same type of question, so I'm going to kind of skip that with you guys. I'm also going to skip question 4. We'll come back to this one. But this question 4, it's a terrible question for this section. I apologize for giving it to you. We can go through it, but it makes a whole lot more sense when we deal with isosceles triangles. But let's come back to this one here. We want to set up some congruencies here. Okay, it says triangle DER needs to be congruent to triangle whatever. Okay, so we got to figure out how to name that. And if I start at D and I went to E, so I traveled down, the segment had 3 marks in it, right? So that sets me up to either start at N or to start at O. Which one should I start at? Because when I name DER, I need to then follow down that marking there, right? And that has 1 hash mark in it. So I need to start at N, go to O, and then finish at M, right? So N, O, M is that triangle. Now here's the use of having that name, because now in the last class we went ahead and filled things in the picture. But now that I have that name, if I look at angle M being 60 degrees, what should angle M match up to? Angle R, right? They're the last letters. Okay, they're corresponding parts. So I want to say that 60 is equal to 2x plus 2y. M and R should be corresponding angles, so those two things should need to be equal. Then they start talking about E. Okay, so I'm going to look at E, middle letter there. O, middle letter there. So E and O should be equal, right? So I'm going to say 50 is equal to x plus 3y. How do I solve that? Okay, so what variable do you want to get rid of then? X. What do you need to multiply everything by then, Cameron, if I want to get rid of x? Because that's a 1 right now, right?
Yep.
So what's it need to become when I add straight down? 3. To give me 0. It is 3 right now.
-2.
I need it to become, because I want those to go away. So doesn't the 2 and the 1 have to be opposites?
-2.
So I need to multiply the bottom one by -2. So the top equation is going to stay the top equation, right? But the bottom one, everything is multiplied by a -2. So it gives me -100, -2x, -6y, right? Now those are the two that I want to add together. So doing that, I get -40. What happened to your x's? They disappear. They canceled out. And now I'm left with -4y, right? So y ends up being 10. Okay. Last week I was over here in Algebra 2 class talking about systems and equations. Okay. You've dealt with them in Algebra 1. You'll deal with them a lot in geometry, and you'll deal with them again in Algebra 2. And my hopes is that once you get to Algebra 2 and you deal with systems in that class, like that's kind of like a couple weeks off to you because we've seen them so much, and you automatically know how to do them. Makes things a whole lot easier for that course. Now that I know what y is, I can plug back in to any of the 2 red equations that I created, and I can ultimately plug back into the black one to find x. However, plugging back into the black one probably doesn't make a whole lot of sense because it's a probably a larger equation in regards to its coefficients than the other two. I want to do it a different way. I want to, because this is somebody asked this in the last class. So how did you know to do using elimination? I just knew that I could. Okay, I'm not saying that that's the best way. I'm not saying it's the only way. And I'm not even saying that X was maybe the only set of variables you could have canceled out. You could have canceled Y's out. Okay, I see it this way. I look at that equation, and I see that X is really easy to solve for, isn't it? Could I say 50 minus 3y is equal to X? Okay, so now what I'm going to do, if I've solved for X, now I'm going to take that and we'll plug it back in to the other equation. So I'm going to take this X here and plug it in right there. But it's no longer X. I'm going to rewrite it as 50 minus 3y. So I get 60 is equal to 2 now times my X, which is 50 minus 3y, plus then 2y. All right, do my distributing process there. I get 60, I get 100 minus 6y plus 2y. Move my 100 over, gives me negative 40. Combine my negative 6y and my 2y, gives me negative 4y. Now what's y got to be? The same 10 we found using elimination, right? Here's why I like substitution better. Because if I'm going to use substitution, I'd probably say 90% of the time, I'm going to initially solve for one of the variables that I'm looking for. Okay. Sometimes I might solve for 2x or 3x or 4x, just depending on what the other equation I'm going to substitute into has. But most of the time I'm going to solve for just singular 1x. Well, now that I know what y is it really easy to plug back in to that equation and say 50 minus 3 times 10, so 50 minus 30 is equal to x, and I get x to be 20. Okay. I think that's easier to find that second variable when you use substitution than it is to find a second variable when you're using elimination. Okay? And I think that because that's simpler, a lot of times people say, well, this question sets itself up for elimination better, or this one sets itself up for substitution better. I don't know. In some cases, yes, that might be true, but in general, overall, I don't know if that's always the case or it is going to be the case, because I think it just creates different math at different spots. Okay. In regards to time, I don't know that it's going to save you much time either way. Okay? I think it's very beneficial to learn both techniques because in other areas of math, it's going to be necessary to use both techniques. All right, this one here, again, like I said, it's a terrible job on my part to provide a question like this, but we can go through it. And you can create, what we're going to do is we're going to create a triangle, M, N, O. It doesn't matter where M, N, and O show up in this triangle. I'm just going to put M there, N there, and O there. And when I'm done, I can show you that it doesn't matter where those go. We'll rotate and still get the same conclusion. So you could have put M here, O there, and N there. Does that kind of make sense? Now, like I said, this will make a whole lot more sense when we talk about isosceles triangles. But we know those two angles are congruent. Okay. We talked about this before. If I have a line here, let's just color this line blue. And I have a point that is not on that line, that one there, O. How many lines are there that will go from this point here perpendicular to this one down here? One, right? And I'm going to say I chose that one. Okay? And if it's perpendicular, that angle and that angle there are congruent, correct? I'm just going to call this point down here X. Would you guys agree that OX is congruent to itself? Okay. Now, the one thing that we might not know yet, and this is my fault, this distance here is exactly the same as that distance there. So now, if I look at this, do you have side, angle, side, and side, angle, side? So these two triangles are congruent, and it tells you basically that segment there and that segment there are congruent. Okay. And NO was 3x plus 5, and MN MN was 7x minus 10, not really something I need for this question, just extra information. And OM is 5x minus 7. So those two things are equal, right? And that's how you're getting then the values for NM, NO, and MO. Like I said, you set that equation, you solve that for x, and then plug back in. Not a great question on my part. I should probably give you a little bit more instruction. But we'll come back to that when we get to isosceles triangles. Because when I see that right there, that tells me this figure is isosceles. Okay, we'll talk about how we know that later on. I want to talk somebody. All right, so this question is ask you to determine if these two triangles are congruent, right? Okay, now, when they start giving you ordered pairs like this, you should instantly start thinking a particular formula or a particular collection of formulas. You should think, from now on, the first thing that comes to mind, especially when they say congruence, should be the distance formula. Okay? As we move into the next couple of sections, the next couple of chapters, the midpoint formula will come back, and the slope formula will be important. Those three things are what we want to talk about. But when they use the word congruent means to us distance, right? Okay, that's what we're, in regards to ordered pairs in the quadrant, four quadrants, or the XY axis, whatever you want to call it. We can't find angle measurements yet. We don't have enough geometry and ultimately trigonometry to find angle measurements. So we're not dealing anything with angles here. We're dealing with sides. And so the only way that I can show two triangles congruent in the XY plane is to find the lengths of all 6 segments. Does that make sense? Okay. And then once I find all those lengths, make a conclusion based off their measurements and how they relate to them. If these two triangles are congruent, so if triangle ABC is going to be congruent to triangle DEF, don't we know that AB's length and DE's length have to be the same? I'm just going to kind of come over here and write some things down that I know should be true if these two things are congruent. I should also know that BC and EF should be equal. And then AC and DF should be equal. AC and DF. Okay? My thought is on this question, because it's just a yes or no question, maybe some of us were just going to roll the dice and click yes, right? Is that what you did?
Maybe.
I know that's what you did. If you did it, that's what you did. Did you do it?
What?
The homework.
That's
Okay. So AB equals DE, BC equals EF, and AC equals DF. The reason I want to go through this is because on a test, hopefully you think I'm a little bit more intelligent than this, and I'm not going to give you a question that's just a yes or no. Because I know some of us will say, I'm going to roll the dice, and I'm going to just choose yes. Okay. On a test, I'm going to ask you, why do you know it to be yes, or why do you know it to be no? I'll have some things to plug in. Maybe I ask you to initially find these lengths, and then I give you a yes or no after that. Does that kind of make sense? So you have to be able to do this process. And the process is something we've been doing. It's the distance formula. Distance is equal to x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 squared. Okay? We need to be able to do that. And what's kind of maybe a problem with this question is that we got to do it 6 times. Okay? We got to do it for AB, DE, BC, EF, AC, and DF. So it does get kind of time consuming, but if you set up a strategy and you understand really what this is saying, it's a lot easier than what you might initially think. This says subtract your x's and square, right? If we understand that idea, what we've talked about all year, when I square something, it's going to take it, if it's positive and I square, it's going to stay positive, right? If it's negative and I square, what's it going to become?
negative. Positive.
Positive. Like negative 5 times negative 5 is positive 25, right? So I don't really care whether that number in there is plus or minus. Does that make sense? Positive or negative. So I don't care how I subtract the x. I just know that this means subtract your x's and then square that quantity. This says subtract your y's and then square that quantity. Okay? So we're going to go through and we're going to find some of these things. Now, what I have, and just understanding how my mind works, how in the past I've seen questions like this and I've messed them up. I know that when I look at finding A, B, and I look at them written in that manner, that orientation of one another, in a list like that, I do a lot of like 3 minus 5, and then I'll accidentally do like 3 minus 13. Or I'll accidentally do 9 minus 5. Okay? I'll subtract x's and y's, and I shouldn't do that. Does that make sense? So what I always do, and I know that that's been an issue for me in the past, so what I will do, when I want to find the distance of AB, so we'll write it this way. A lot of times when we find distance of something in the parentheses here, we'll talk about what that segment is. Okay, so distance of AB. What I will do is I'll take A and B and I'll write them on top of one another. I'll go 3, 9, and then 5, 13. Because now visually looking at it, and that's how you like add and subtract, right? Okay, if I were to give you like, do it by hand, take 9 plus 13, you're going to stack them on top of one another, right? Or if you subtract, you're going to stack them on top of one another. So that's what I do. And now it doesn't become an issue. I know I'm never going to go across and use 3 and 13 together or 5 and 9 together. I'm going to subtract straight down. So what's 3 minus 5?
-2.
-2. But I don't care about the negatives. I'm going to square, right? So if you want to keep the -2, keep it. If you want to make it positive, make it positive. So -2 squared is
4.
4. And the reason I can just keep it positive if I want to, because 2 squared is still what?
4.
4. So no matter the order that I subtract, because I get either -2 or positive, when I square it, I always get 4. What about 9 minus 13? What's that get?
3. 4.
-4 square that? 16. Okay? So AB's distance becomes radical 1. Radical 20. Okay? Don't simplify that. Okay? I know if you type it in your calculator, it'll give you 2 radical 5 back, right? Okay? And we'll talk about how we do that algebraically later. But don't simplify that. Okay? Because if I leave this one as 20, radical 20, and then I simplify this one eventually as 2 radical 5, you might visually look at those and say they're different, right? But they're actually the same. Right? So leave them all unsimplified when we're trying to make this comparison of segment lengths. All right, so that was AB. So now let's do DE. DE. So this thing's kind of DE. So we'll go 4, -5, and 2, -9. Okay, so this is distance D to E. Subtract your x's. What do you get when you subtract your x's? 2. Square that. 4. Subtract your y's. Now, be careful here, because you got a negative minus a negative, right? So negative, and if you know you're a person that struggles with it, write it down. -5 minus -9. What's that become? 4. Square that, you get 16. Okay? Add those together, I get radical 20 again, right? A lot of times when I do that, so when people do that subtraction, I get a lot of -14 answers or positive 14, stuff like that, right? Okay? The minus and negative turns into addition. Okay? So -5 plus 9 gives you that 4. So, right now, we have a side congruent to a side, right? We need to go through and find BC and EF. Okay? And we need to go through and find AC and DF. Does that kind of make sense to everybody? All right? And once we do that correctly, we should recognize whether it's a yes or a no answer. Okay? Now, what I'm going to do, just for the sake of time here, to get the right answer, to convince you, GeoGebra does this. Okay? But it does it a lot quicker than what we're able to do by hand. So see if we can make the same judgment.
Where you put in the points?
Huh?
Where you put in the points?
Yeah, I'm just going to put in those ordered pairs. So 3, 9, and 5, 13. So A, let's go 3, 9. We'll go 5, 13. So it's A, B, C was 9, 5. So there's one triangle, right? ABC. So I'm going to just create those segments. Okay. The other triangle, DEF, for -5. 2, negative 9. And negative 2, negative 1. Okay, so you see that they're not in the same orientation of one another, though, right? They're not like this one here up here has been slid and becomes this one. They've been rotated or flipped. But what I like about GeoGebra is that we can say this AB and DE, right? They became 4.47, okay? And if we were to take our calculator, the radical 20 that we came up with, okay, radical 20 is a little bit less than radical 25, right? Well, radical 25 should give me 5. So radical 20 should give me something less than 5, but not too much less than 5. So it gives me 4.47, and that's exactly what GeoGebra is giving me here with those two segments. So we get AB is congruent to AB. Does that make sense? Or sorry, AB is congruent to DE. We then would have gone and figured out what BC and EF. So BC is 8.94 and EF is 8.94. So right now with those, we have side congruent to side and another side congruent to a side, right? So it's SS so far. And then we want to do the last segments. AC. AC's length is 7.21, and this one here is 7.21. So now I do have side, side, side. Does that make sense, everybody? All right. But what GeoGebra was doing in the background is that distance formula that we were doing by hand. Okay. On a test or a quiz, I need you to be able to do it by hand. On the end of course exam, they ask you to do it by hand. All right. And there's a lot of questions on the end of course exam that might reference you to deal with the distance formula. Okay. Now let's say we go through this, and let's say I find A, B, and D, E to be the 4.47. And then I find maybe B, C to be 8.94, but I find E, F to be 10. Can I stop there and say the figures are not congruent?
Yes.
Yeah. Once you find, because we can only use side, 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 right? We can't use side angle, side, because we don't have the knowledge yet. We don't have the knowledge yet to be able to find maybe that 29.74. Okay. So we have to stop there and say, well, they're not congruent by side, 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 because one set of sides are incongruent. So we break that postulate. Eventually, we might have the ability to use 29.74 and find that angle, because we will talk about trigonometry. We'll use sine, cosine, tangent. We'll use law of sine, law of cosine, things that maybe we haven't heard of before. But when I want to find that 29.74, you listen, Cameron? Yeah. When I want to find that 29.74, guess what information I need first before I can do that? I need that 4.47, I need that 8.94, I need that 7.21. So when we do want to eventually look at the angles, it's still important, it's necessary to know the distances, okay? So we need to make sure that we understand the distance formula and we can pull from it and use it consistently, okay?